So we went over some of these. I think you guys actually, I think you got more questions in yesterday, and it clarified some of your maybe misconceptions. So I think you guys might be good. Yeah. Like.
So you just replace.
Yes. So the ending, because it sounds stupid to go lithium carbon. Something you've probably heard before is like sodium chloride or carbon dioxide. So that I didn't think it's something you maybe heard before, but it just ends everything off in a similar pattern. And don't forget, ides mean they come straight from the periodic table. So just element from periodic table. So carbide means carbon. That's why you're not trying to figure out what the heck does carbide mean. It sounds like carbon. Come on. More questions through 10 right now. Like, be honest and tell me if you don't understand something, because this is the first of lots of nomenclature. Yeah. Alex.
Can you do 12?
Yes. And then question?
Oh, I was gonna ask if, like, with the 8, like, just where the number came from, like with the ones that end in "ide," where do you get the number from?
Let's see if somebody else can answer that. So if it ends in "ide," it's coming straight from the periodic table, but they're still ionic compounds, right? So where are these numbers coming from? These subscripts that we write down. Like, for example, how does 3 get here? It's the charge of aluminum. It's not really anything about fluorine. I know there's 3 atoms of fluorine in this compound, but that 3 actually came from the original starting point of aluminum 3+. Fluoride was. Fluoride, you can tell from the formula what charges of fluoride is. 1. Okay, so it comes from the charges. So that's like, anytime you see a metal, you should automatically go ionic. And if you think ionic, you're saying the word ion, and ions have charges. So if you see a metal, you're like ionic. Find the ionic or ion charge, crisscross them down. 12. So nickel 3 thiosulfate. Thiosulfate is this weird, humongous S2O3 2- polyatomic. My bad. 12. We did thiosulfate yesterday, I think. Barium acetate. So barium is going to be the metal, so you just write barium with its charge. And then acetate, the 8 ending says, I'm a polyatomic ion. And then you look on your sheet for now. C2H3O2, C2H3O2, 1-, sorry. And then you have your 1- charge, sorry. C2H, 1- charge. I think that you will really appreciate your parentheses over and over again because it keeps it a little kind of more tidy. And then when you crisscross the 1 down here and you crisscross the 2 over here, you end up with subscripts of 1 and 2. Yeah.
What do we do with this school? Do we have our little sheet?
That's what I'm trying to get you guys to start now. And I had one person in my IB class tell me they remember some of these polyatomic ions in some weird ways, and he wrote them up here in like nanoscale writing, okay? But we have sulfate is soft. Sulfur, oxygen, 4,2. SO42, soft. And then he said chlorate is cloth. Cl, so chlorine, oxygen, oxygen. Cloth has 3 letters. He's actually told me to come back and explain it. It's going to be a crutch for the rest of your life if you don't, for the rest of your chemistry life, if you don't. So that's what I'm trying to get you guys started now. Right now I'm babying you. But trust me, it'll take you, I'll take your crutch.
I'm going to fall on the floor.
But you will learn how to walk, won't you?
I'll learn how to crawl.
Or die, okay? So it's something that you, in the end, will be better off with, okay? So any more questions through 14? Through 14, okay, be quiet because some people might have questions, yeah?
Why is it nitrogen 4- and why is it 3-?
Nitrogen is in the 5th group, yes? Is nitrogen in the 5th group?
Yes.
So if it's in the 5th group, it either loses those 5 valence electrons or it gains 3 valence electrons. Because it's going to bump up 3 to look like that of a noble gas. So that's when it chooses to gain 3 electrons, therefore it gets a 3 negative charge. All right, now you guys tell me the names of these. I already have a couple of these highlighted. And I know we went through some of these yesterday, but say them again for me. You need to speak your language or you will not be able to speak it. First one. So the ammonium was the ending there, and 8 sulfate was the ending there. Okay, keep going.
Calcium phosphate.
Calcium phosphate again. So those are big polyatomics. And I didn't have a box or parentheses around that one, but your goal is to always identify the metal in the beginning. The rest of it's got to be polyatomic ion, especially something like number 4 down here. Number 4, you see lithium, then you see carbon, and then you see oxygen. But you should not see carbon and oxygen as two separate entities. You should see it as a polyatomic ion called what? Carbonate. Okay, don't call it carbon oxygen, it's carbonate. Right, so that's lithium carbonate. I missed one, sorry. What's number 3? Calcium oxide. So the ide ending is a simple binary compound. Next one. Potassium bromide. Good. Has an ide ending. And I went ahead and wrote these because I want you guys to realize it's always a first name, one last name. You don't get to name it like 3 different things. Okay, so this whole thing is its other name. Actually, no, y'all's I think I fixed to be C2O4. Yeah?
Yes.
So, there you go. Tell me what yours is. Calcium oxalate, right? C2O4 is oxalate. Next one. Why are we saying 2 here? Tell me more. You have to account for the transition metals charge, because if you don't, my big question is going to be, what is the charge of copper? So copper is a transition metal, and that's one that has variable charges. It can be copper 1 or copper 2, so you state it. Why are you not stating, like, calcium's charge? Because it's set, right? You don't have to tell me. All of us know how to read periodic table where, like, calcium has a 2 charge. Nobody has to say it. We all know it, though. That's why copper is different, because it doesn't have a set charge. All right, so that's copper 2 dichromate. Next one? Sodium chloride. I heard it. Okay, ite. Next one? Iron what? Why 2? Tell me how you backtracked and found it was 2.
Oh, because CO3 has -2 charge, or 2 negative charge, too much.
You're going to say 2 ones, yeah.
Yeah, and Fe had 2 charge.
So if that 2 went down there, well, it's not there anymore. So what does that mean we did?
You can't.
We reduced it. So it previously was 2 and 2, not 1 and 1. So that's how you knew iron was a 2, 2. So that's iron 2 carbonate. Again, 10. Iron 2 phosphate. And that one's easy to see because the 2's like, hey, I'm right here. There you go. So iron 2 phosphate. 11. Nickel 2 chloride. So we had a lot of transition metals right here in a row. That's why you indicate their charge. 12. Strontium carbide. Ide ending because of the poly. It's just simply one symbol, one element. Did we do 13, 14 yesterday? I don't remember. What's 13? Ooh, no mono here. Aluminum.
Phosphide.
Just say phosphide. Just go straight for the chase here. So phosphorus goes to phosphide. Last one? Aluminum phosphate. So I know it sounds like little details, but in our next 3 units, we're going to be using all these things in chemical reactions. So if I say, all right, go react aluminum phosphide with nickel 2 chloride, you're like, what is she talking about? You're not going to be able to do anything past that because you're stuck on the name. So this is really important that we keep practicing. And it takes a while to sink in, so I'm peppering it through for the next couple of days, okay? So ionic is a beast, okay? Covalent is like a piece of pepper. It's little. It's so easy. So I already know that you know some covalent. This is on your paper, by the way, down here. It's in a little box. It says prefixes. Yeah? All right, so let me give you an example, and then I'll show you how to use the prefixes. If I told you to name this, first of all, you're very, it's right underneath ionic. If you look at this, tell me, is it ionic or covalent? Immediately. How do you know it's covalent? Right, non-metal, non-metal. So that's easy. Tell me, is that covalent? Because it's 2 nonmetals. Okay, so immediately, kind of your first step is like deciding if it's ionic or covalent. Deciding it's covalent means that you get to get this done in about a second. Because the way you describe covalent names are simply by noting it prefix, and that prefix is mono, di, tri, tetra, penta, hexa, hepta. These are the, I think tetra is the one most people get lost on, but the other ones like sound like the geometric, whatever phrase you guys use for naming polygons. Polygons, and what are the 3D ones? Polyhedrons. Yeah? Okay, whatever. Mono, di, tri, tetra, penta, hexa, hepta, octa. Dodeca, deca. We have a couple of others. But those prefixes describe how many of each of the atoms you have. So this name is carbon, but I don't say monocarbon because monocarbon sounds stupid. If you just say carbon, everybody assumes you're talking about one of them. And then how many oxygens? Di. And then oxygen changes to oxide. Okay, carbon dioxide. You've been saying that for probably like 3 or 4 years of your life. Okay, why? It's because carbon, there's one of them. Di means 2. Oxygen turns to oxide. So then can you name this one for me? Di, hold on, there's 2 nitrogens. You do have to tell me that one. Dinitrogen. Tetroxide. And I'm just going to put tetroxide just to combine that. Okay? Dinitrogen tetroxide. Yep. Yeah. Yeah. So that was another example. So in this case, I do have to use the word mono because when you want to put mono in the front, just stop yourself. Just don't do it. So don't put carbon up here don't say monocarbon or monocarbon because that's the first element. If you don't say a prefix, I'm assuming it's 1. But if you don't say a prefix in the back, I'm going to say, well, they just don't know. But this one, you want to note that it's a 1. So you say carbon monoxide to indicate there is 1 oxygen. It's just that would sound really dumb if you said monocarbon monoxide, right? It's just carbon monoxide. All right. So give me 2 more nonmetals. Sulfur, fluorine. I heard. Okay, let's do that. Name it. Say it. Say its name. Silver hexafluoride. If you suck that in, it makes your voice really, really deep. But like helium, it makes your voice really, really high, right? So that's actually makes your voice really deep. Anyway, so sulfur hexafluoride. So I don't think anybody's even looked at the periodic table, right? Do we really need to on these? No, you don't look for charges. You don't even probably, unless it's a weird element, you don't even look for their name because everything's in the picture. Everything's right here. But now I want you to go backwards. I want you to go from name to formula. And it's easy because the prefix is literally attached to what it's going to describe. Okay, this is on your paper, I believe. Yes? Okay, so quickly go through these for me. I know the first one's CO2. I know the second one we just did was CO, carbon monoxide. Next. I hear you, P2. O5. Diphosphorus pentoxide. Next.
H2O.
N2O. Good. Monoxide. Good. Next. SiO2. And that's actually like quartz. That's sand. Silicon is on that metalloid line. So sometimes you're like, is it ionic or covalent? The way you figure out if silicon is going to act ionically or covalently is because when you read and you say silicon dioxide, there's a humongous prefix there. What's that prefix kind of telling you it is? Well, I know it's telling you there's 2 oxygens, but when you see a prefix, you don't see prefixes in ionic compounds, right? You don't see prefixes at all in ionic compounds. You see prefixes in covalent compounds. So it's telling you, I'm a covalent compound. Just give it to me like it is, SiO2. No crisscrossing, no nothing, no funny business. Keep going. C4. Next. SO2. Phosphorus pentabromide. PBr. Penta. Penta is 5, right? Iodine trichloride. ICl3. Nitrogen triiodide. Ni3. Dinitrogen trioxide. O3. Covalent is a piece of cake, people. If you got ionic under your belt, you need to keep working on it. Covalent's in the back burner. It's not something you can mess up unless you start getting crazy with your prefixes and you try to use them for everything. So I intentionally actually wanted to say this one because if I taught you prefixes yesterday, your entire paper right now from ionic would have been filled with prefixes. Because this is so easy. You're like, yeah, let's just use prefixes for everything. No, you absolutely cannot. It's only for covalent. So, and you can see we just said I, and we said for the first element, don't put a prefix if it's mono. And I think that's all for covalent. Can we just say these couple of names out loud? So, like, tell me that's name, number 5. I heard di. Okay, di. Arsenic. Pentoxide. Can we say number 7? tetrachloride, carbon tetrachloride. Okay, number 8. Dihydrogen
Oxide.
How many?
Monoxide.
Monoxide. Dihydrogen monoxide, or AKA water, right? That's lame, but that's just water. All right. Last one. Selenium hexafluoride. Selenium hexafluoride. I think you guys feel smarter already. You guys know so much more chemistry. Crazy. Okay, so I want to do acids nomenclature if we can get through it at the end of class, because you'll start problem set 9 this weekend. You'll get through 70-ish% of it. Turn your phone off, please. Thank you. You'll get through about 70% of it because there's going to be a couple of acids in there. But you need to start looking at it first. Like what I would do is do all the covalents first. That way I got that easy peasy part done. And then go and do all my ionics. Just because that's going to take longer. But we're going to really solidify this because this is one of the hardest parts, is memorizing and knowing these things and remembering how to apply it. So pull out the polyatomic ion list, turn on the back page of it, and it's got some instructions for an assignment you're going to start today. And I think everybody got one of these pieces of paper. It's called the nomenclature skit. And I feel that if you can teach it, you know it. If you just read off the paper and you kind of just go with the flow, you don't know it. So this is my way of making it more fun to learn nomenclature. So basically, I'm not going to read all these instructions off to you, but you'll see you are going to do in partners. I can allow for partners of groups of 2 or groups of 3. You have to make a script for me so that I can approve your script before you do your skit. The skit doesn't have to be like a theatrical production. It can be a song, it can be a rap. I got one group doing puppets. They're going to do like sock puppets. You be creative. I got one group doing like, we're going to be superheroes and we're going to teach it. I was like, that is awesome. Okay? Go crazy. And you'll literally see creativity is a requirement. The crazier the better. Okay? This is a requirement. Listen before you start talking to your groupies. You have to go from name to formula and formula to name for multiple things. You must include at least one transition metal. You cannot repeat any elements like calcium, calcium, calcium. That's kind of boring. Yeah. Okay, so basically today I would like for you to decide on your examples and get your script done. Okay, I'm going to give you guys about 45 minutes right now. My last class, 90% of them got it done. Okay, and I'm going to ask for you to type it up for me because I need to see it so I can approve it by the weekend. The MacBooks are will attach to Wi-Fi. The Chromebooks are having some problems. You can try both. Okay, get in groups of 2 or 3. Decide on examples. Script.
The MacBook.
Yes, thank you for reading. Be happy.